Hey, this is an addendum to my previous video that was looking at the question, if you're on a spacecraft traveling from the Earth to the moon, how far do you have to get to the moon before the moon's gravity pulls on you stronger than the Earth's gravity does? And so this addendum is for actually going through the detailed math of the solution that was given in that video. So if you haven't seen that previous video, you might want to watch it now for the setup. And but here was the upshot was that we ended up with this quadratic equation. Quadratic equation just means you have something in the form of something times x squared equals something else. And in this case, the something times x squared is big M minus little m, the Earth's mass minus the moon's mass, plus 2md times x. D is the distance from the Earth to the moon. X is what we're trying to find, by the way, the distance from the moon where we have this gravitational balance. And then this constant of negative m times d, that's a little m, the moon's mass. And so this is an equation in quadratic form. And so in algebra, you probably learned the quadratic formula, which is that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so if that looks familiar, and if when you first learned that you were wondering where in the world would I ever use that, well, this is a situation where we need this equation. And these quadratic equations come up often in science and engineering. And so having to resort to the quadratic formula is part of being a scientist or engineer. It comes up fairly often. And so let's go ahead and plug in the numbers here. What this is saying is whatever it is that's being multiplied by x squared, that's our a. So in other words, this equation, the quadratic formula rather, is a solution to this equation. Ax squared plus bx plus c is equal to 0. And so in our equation, in this particular situation, the thing that's multiplying x squared is big M minus little m. So that's our a. 2m times d, that's our b. And our negative md squared, that is our c. And so big M minus little m, 6 times 10 to the 24 minus 1.7 times 10 to the 22. And so when we get that, we end up with 5.9 times 10 to the 24 kilograms. I have previously calculated those. I've got them written over there. B, 2 times the mass of the moon times d. So B is 5.7 times 10 to the 28 kilogram kilometers. So if you use this in an algebra class, there are probably a couple things that are different right now that make this look especially daunting. One is we're using scientific notation numbers. These are big numbers. And so remember, the 10 to the 24 means you move the decimal point 24 places to the right if you want to write it as a regular number. But we don't, because that gets tedious writing all those zeros. The other thing that's a little weird that you may not have done in an algebra class is have units. So A is the mass of the Earth minus the mass of the moon. So it's going to have units of kilograms. And B is 2, which doesn't have units, but the mass of the moon times the distance. So the units are going to be kilograms times kilometers. And our units here for C, the units are going to be units of mass, kilograms, times the unit of distance squared. Here we're using kilometers, so it's going to be kilogram kilometers squared. And the actual number is negative 1.1 times 10 to the 34 kilogram kilometer squared. And so these are our A, B, and C now. And so we can go ahead and we can plug in. We can say x is equal to negative b, so negative 5.7 times 10 to the 28, plus or minus square root. I'm saving space here by not writing the units, but the square root of b squared, so 5.7 times 10 to the 28 squared minus 4 times a, 5.9 times 10 to the 24, and c, negative 1.1 times 10 to the 34. Now be careful here, that's multiplying by a negative number, that's not a subtraction here. And all of that here is under a square root. And everything is over 2a, so 5.9 times 10 to the 24. So the things to worry about are punching in the scientific notation correctly on the calculator and being careful here with the minus sign. In fact, it might even just be easier to say, well, I'm subtracting a negative number, so I'm going to go ahead and get rid of that minus sign and just say I'm adding. And then that's just one less thing to mess up when you punch it into the calculator. But when you do that, you punch it into the calculator, you get 38,500 kilometers as x. And by the way, I'm only taking the addition here, the plus sign in the plus or minus. So that gives us our value of x, and that is the setup and a delightful example of using the quadratic formula for a practical question. If you're going to go to the moon, how close do you need to get to it before you are more strongly pulled to the moon than you are to the Earth?